Good afternoon, Professor.
Yes, you win. Good afternoon. You beat me to it. That's awesome. You totally win. And actually, wait, now who was that's good afternoon to you. But I'm saying you, and this is my bad partly. Oh, and good afternoon, David. All right, I'm gonna start. That's all. Oh, and good afternoon, Kate. Oh, okay, here we go. That's awesome. But who, sorry, not to be, but who was that actually? Was that a man? I can't see because of the man. Who was it that just said good afternoon, Professor? Could I ask? Oh, I can't ask. I mean, I could ask, but I don't get it. Okay, well, that's awesome. All right, here we go. Okay. But thank you for saying hello. You guys are already way ahead of me here. So hello, Kate. Hello, Amanda. Hello, Caroline. Hello, David. Hello, Kimberly. Hello, Savannah. Hello, Samuel or Samuel. I think it's Samuel. I'm not sure. Okay. Hello, Elda. And now I'm going to the thing. But who did? Anybody gonna own up to saying that? It's all right. I guess I'm okay. Good afternoon, David. If I didn't say good afternoon, Caitlin. Oh, I did say, but it's okay. Good afternoon, Savannah. Hi, Caroline. Good afternoon, Amanda. Hi, Christina. Good afternoon, Felicia. Good afternoon, David. Oh, that was okay. Oh, all right. Fair enough. Fair enough. Totally noted who that was and noted. And I note that it's for me only to note. Fair enough. Well done. Okay. Good afternoon. Wait. I did this last time. I know. See, I'm going to keep double psyching myself. I'm going to keep double psyching myself. I want to say Jamalet now. I won't, but I'm not. I'm getting.
Yeah, it's Omelette.
It is. It is. Okay. Okay. I'll only get that wrong 14 more times. I promise. And then on the 15th or by Physics 204, I'll have it right. Okay. Awesome. Good afternoon. And good afternoon, Amy. And good afternoon, Kimberly. And hello, Kevin. And good afternoon, Adan. And good afternoon, Elda. Good afternoon, Samuel, which I think it's Samuel, but you'll tell me or you'll privately tell me.
You said it right.
I did. Okay, thank you. And I love the road. Okay, great. Thank you and thank you. And this all counts as participation, as we all at this point clearly know. And you guys are all way ahead of me and I'm behind you. We'll talk about that. Although we're going to do more physics today. Hello, Sophia. Oh, and someone's in the waiting room. Right. Okay. And good afternoon, Alicia, which I think is Alicia. You go through that already? Did I already? That's right. Okay. Thank you. Awesome. Okay, great. Thank you. Thank you. Appreciate it. And again, not to be and good afternoon, Chloe, which I think is Chloe. And again, not to be weird, but we're still in the stage. Remember, we're still in the stage where like I just want to like point out every right thing that happens, or just every opportunity to get more points. I want to point out. So just remember also, like, all of you are definitely, it seems like you're all getting the routine of the turning in the game turns once a night before midnight. I think you're getting that routine, which I appreciate. Hopefully you're seeing it's not that stressful. But please also note, for example, any one of you who today said like, yeah, that was me, or you helped me with your name using your voice, just please know that you can also double dip. Like you can take the same, oh, I participated today by correcting your horrible pronunciation of my name. Like if you could write that down as your participation. But if you used your voice to do it, you can also submit that in the voice portal, whatever it's called. I think it's called Speak Now or Forever Hold Your Chat or some dumb title like that. Just remember, anything that applies. You can take the same submission and apply it to as many portals as applied. You don't have to retype it or anything like that. And if I ever write on your homework, on your participation, if I ever say something like, you can double dip this, that's what I mean. Like I'll try to get less and less explanatory about that as we go on. But anywhere you can get points, take the points. And you're doing me a favor when you do that too. I just rather, my ideal is that everybody gets an A that they deserve, right? So like if you just make it easy for me for you to get an A, like they were anyway. Okay, you get that. All right, we're gonna start in a second. So hopefully I've said hello to everybody and you're all here and it's great. And you guys have been turning in things, and I had totally forgotten that we didn't have school on Monday. That was my bad. And now I am behind you. I want to say right now, actually, wait, well, we're gonna get going here. Hold on. Yeah, we're gonna get going with the actual physics topic, which is one-dimensional kinematics. That's the chapter or the topic that we're on right now. I mean, really what we're on is homework 1. I'm going to get back to homework 1 in a second and just continue to go over it I know that we only got up to one question last time. We're going to go faster and faster, I promise. Again, remember that we will go faster and faster. The idea is you'll be able to go do more and more without my explanations as we go. Also, remember any systems that we're setting up here or any suggestions that I'm trying to give you here about physics in general, they all apply to physics 204 as well. I mean, the grading system, everything. So if you do take physics 204 at John Jay with me, then all of this is an investment for 2 semesters, honestly. So we're going to get to the number line in a moment. We'll hopefully move faster through it today. Then we'll proceed on to average speed. I want to make it clear that I'm aware that, in fact, I'm going to acknowledge in a second, tons of you have turned in a draft of number line and you've not gotten it back yet. If you have not gotten it back, that is not because I don't see it. It's not because you did something wrong or anything like that. And it's not personal. It's that I've already somehow fallen behind. Again, you may find today, or all of you have opportunity to revise, to hand in another draft, to fix things, either once you hear things today or once you get the grade, or the number, you'll all be able to get a full score of whatever it is. I forget what it's worth. It's worth 20 points or 30 points or something like that. Whatever it is, I will let you know when it's become too late for you to get all the points. But we're definitely not there yet, especially because I haven't even given, if you haven't gotten the comments on it yet from me, that is me, not you. Hold on, there's something in the chat, but we're going to start going over. We're going to continue going over it again in a moment. And if you can use that to your advantage, great. Oh, wait a second. Oh, no problem. Thank you, private chat person. No problem. Thank you. So we're going to go to number line. As I said, again, though, please, every day I'm going to try to go a little faster. And I know from these, from the recordings, I know how inefficient it feels at times. I know that I talk a lot and say very little. Bear with me. I'd rather err on that side at the beginning, but still, please take that as a sign. All of you, any of you, at any moment, please interrupt. It's not an interruption, even if I act like it is. Like at any moment, you can interrupt either to slow things down if they ever get too fast, or to say, can you go back a page or go back a sentence? Or you can always say, like, I know you already said this, but I didn't catch it. Can you re-explain to us the blah, blah, blah? I'm a firm believer that honestly, people need to hear things more than once. It's not a shame. But similarly, you can always any of you can private chat me and say, I think we get it. I think you could move on now. Really, if you say it politely, I will not be, you might want to try to say it politely, but you can also interrupt me to move me forward. Really, you can. And if in the background, you're having a private chat where everybody's like, can he already, you can speak for the group. Okay. So I'm going to do that. I'm going to, so please interrupt me at any time. I'm going to keep watching the chat and stuff, but I am also going to change the view here. All right. So we're going to get to the number line. One other quick thing, you notice, or hopefully, so again, if you just walked in, you're just tuning in. If you have not gotten back yet, homework 1, that's on me, that's not on you. Oh, and that is something I was going to say. Actually, wait, I do want to acknowledge that. Hold on. This is not, I know this is a weird technique that I do this. It's questionable, but I feel like it's worth it in the long run. I just want to say, so hang on 1 second. Sorry. So there's 2 things I'm going to do before I move on. Right. Obviously, game turn 3 is due tonight. Anyway, okay. But as far as number line, let me just, every single, literally, I'm amazed. Honestly, I was about to read names out loud, but I'm looking right here. I'm seeing, okay, just to make it clear, every single one of you has turned in number line, which is amazing. A couple of you, Google Classroom might say that you're late because a couple of you was after whenever I technically, but every single one of you has turned it in. That's awesome. I'm not even sure, honestly, I'm not sure that there's a semester in recent memory where that was already the case. When I say every single one of you, though, one other last thing, that means every single one of you who is in the Google Classroom. If you're sitting right here in Zoom right now and you didn't, and you don't know what I'm talking about Google Classroom, I don't think that is any of you. But if that's the case, definitely private chat me or text me. You definitely do need to be on the Google Classroom. I don't think that applies to anybody here. But okay. Anyway, so I'm going to go on. Last thing. last logistical item. You might have noticed I've put one more game thing, one more game portal in that's not a turn. It's not the nightly thing. And none of them is mandatory. None of them is mandatory. Not one of them is mandatory. But there's one I just put in that you might want to take a special note of. One of these like more than 5 points worth thing. I put in one just now about called user manual or something for the 5-step problem solving method. Hopefully it's self-explanatory, but let me just highlight. That one you have till October 1st to do. You don't have till the end of the semester because it's not worth it if you do it at the end of the semester. But if you within the next like month or 3 weeks, if you look at that one, that's called user manual, it's worth like 35 points. I mean, that's like a real homework. That's a lot of points. It's optional. But what I'm asking you to do there is literally make up your own typewritten sheet or your own sheet of this 5-step method that we're going to use for the rest of the 2 classes. Like an instruction guide, like that could be used for other students, or you could share with other students, or I could use in future semesters, just to show me if you can explain the 5-step method and make like a nice sheet out of it. That's optional, but if you do that within 3 weeks and turn it into that portal, 35 points. Okay, that's because they'll really put us on the same page. But okay, just to be clear, if you have any questions about that, let me know. But now let me go back. So other than that, I'm going to assume I'm looking at the chat. I'm assuming there's no questions for the moment. So I'm going back right now. We're going to continue with homework 1, number line, right? And I'm going to continue doing it, like doing out full solutions here, maybe a little bit slowly for some people's taste, but a little bit faster than last time. I'm going to do out full solutions according to the 5-step method. So I'm still continuing to show you what I would think you would do for me. Okay, so I'm simultaneously sort of trying to go over the physics and go over the general method of doing these things. I'm going to do it with your help. For example, I'm going to re-put the diagram again super quickly that we need. So you might have to help me with that. I might forget. Like I believe I might need your help with the facts in a second, but I believe, and I know we're going to continue from question 2 here. I believe the professor starts at position 4. Please correct me if I'm wrong, or maybe in the chat confirm that I'm right. And I believe he starts by going like this. And I believe it goes like from 4 to -2, and then it goes from -2 back to 4, and then it goes from 4 all the way to -5. Please, maybe someone in the, and this totally counts as participation. If you could in the chat confirm, or yes, thank you, Caitlin. Thank you so much. That was public, right? Okay. Thank you, Caitlin. I totally appreciate it. And oh, that was a yeah. That was a yeah. Okay. And again, for the record, so Caitlin just said yes, so that totally helped me. But if someone else then says yeah, like don't think it's not a race. If one of you else, even after Caitlin did that, you also wrote yeah, that counts. Like thank you for being alive, even if she just woke you up by writing yes. Good, fine. All right, and then I believe it was 3 seconds, 2 seconds, 3 seconds. Is that right? 3, 2, 3. That I do need someone to confirm, please. I think it's 3 seconds, 2 seconds, 3 seconds. Is that, could someone yes, thank you, Amanda. Awesome. Oh, here comes a quick interruption. Yes, sorry. I can't, I'm teaching right now. Okay, I am in the middle of a class. Your snacks are right here. You're gonna either have to take these snacks or you're gonna have to wait. I apologize. I'm in a class right now. Yeah. Did I mention? Okay. You're gonna be, if you didn't meet, I don't remember if you met him, but you will for sure. Okay. Is it, but it is, and that's Amanda confirming. No, is it, sorry, can you confirm that it's 3 seconds, 2 seconds, 3 seconds? Is that, because I'm, as you see, I'm not looking to 3, 2, 3. Okay, thank you very much. Awesome, Amanda. Thank you. And thank you, Felicia. And thank you, Amy. Also thank you all. The continue, it's also just like a way of saying, yes, I'm here, I'm alive. Like, you know, and I'm psychologically getting your son a snack right now. Okay, all right. So now question 2 then. So we're up to question 2. Oh, and you're definitely gonna have to help me here because I'm not, all right. question 2, I believe, I think I already told you the answer, but okay, question 2, I believe, tell me if I'm wrong, but I believe question 2 is, what is the total displacement for the entire 8-second journey, right? So question 2 is, one way I could write it. Oh, so here, wait, let me be very, very clear. One second. So if I were doing the homework right now, if I were you doing the homework, right, for question 2, first, I would say something like diagram above. Okay. And then okay, the first thing, see. Right. Okay. So good question in the private chat. So I'm not mentioning the person's name, but in the private chat, someone's asking, would I want you to include the number line drawn out if we want to redo this homework? Right. So that's a very fair question. And there's two, the answer is yes. Yes, please. Even if I know that's annoying in a way, but yeah. So on the one hand, yes, for every problem you ever turn in, homeworks and exams, and I do always want you to begin with a diagram. Step 1 is always DFP, diagram and fact pattern, like an ideal diagram. An ideal diagram won't be, it doesn't have to be a proper physics graph or free body diagram. It doesn't have to be necessarily a technical diagram, but some kind of drawing. And the litmus test of the drawing is that in most cases that the labels in the drawing, in fact, I'm going to do this right now, that the labels in the drawing make clear all of the constants and variables, all of the symbols that end up being used for all the equations and solutions to come. Now, in this first problem of the year, mostly I'm doing it in English. We're going to develop equations out of this problem, so we don't really have equations or symbols quite yet. But once everything starts looking like equations, which it will, then the way you know, the way all the work makes sense and stands on its own, if you have an equation like V equals X minus X naught over T, we'll know what we mean by the X and the T and so forth, because they will be labels in your initial diagram. So what I'm really trying to say is, first of all, an initial diagram does have to be there, and it has to contain all the facts and the variable constant symbols that are going to be used. It should present everything. It doesn't have to be a long paragraph of English the way I gave to you. You can shorten all that and shorthand it like I did here. But to be super clear to everybody, because it's a very fair question, even if you think I've said something about this before, let me be really clear. Even if I made a diagram, you still have to make a diagram, yes. Ideally, yours is going to be in your style. You're going to ideally you're going to include all the information that I did, and you might even use my diagram as a guide for sure, but you're going to end up making your own diagram, not copying and pasting mine, making your own. It might look really similar at first, but still it's going to be in your handwriting, So to be very clear to everybody, even if I include a diagram, you have to make a diagram. And often and here's the irony, you might be thinking right now, well, if you already made one, I mean, I wouldn't have thought to do it. I would think, but the funny thing is, it's whenever I forget to make one that people really forget to make one, and you really need it then if I don't need. I mean, in other words, you need a diagram. But so that's answer 1. And if I did answer that, please let me know, and then you get points for closing a conversation loop. And if I'm getting excited, it's not a stupid question. I'm just getting excited. Yeah, great. Thank you. All right. Awesome. Okay. That's totally points. But flip side, now let me tell everybody, yes, I was expected diagram. But for every single one of these questions is going to be based on the same diagram. Excuse me. So what I'm not saying to private chat person or anybody else, I'm not saying you have to keep redoing it. I mean, I'm just redoing it here because it's been like a week since I've seen you guys. So I'm redoing it once here, but on every one of these following questions, I'm just going to write for step 1, see diagram above. You can totally do that, and you should do that. Okay. So I'm literally saying, see diagram above, okay? And then please note too, I'm writing off in the margin. Parentheses, like different color, step 1 DFP. Now, to be as clear as I can be, I'm not saying you literally have to do that in your homework. You don't literally have to label your work with step 1, step 2, step 3. You have to include all the steps. That's where you get your points, is the steps. You don't literally have to label them step 1, step 2, but a lot of people do. And it certainly is helpful for you and for me to do that. You don't have to, because it's like a physics class thing. It's not a physics thing, but okay. But so I'm going to do it here showing you, but I'm putting it off to the side, like in parentheses. You don't have to do that, but I am, just to show you what I'm doing. All right. So step 1, DFP diagram and fact pattern. I wrote C diagram above. So boom. Now then again, that was a good question. Oops, sorry, wrong color. Please do keep these questions coming. Even if you think I've already answered it, it is okay, at least at this stage. So now step 2 is WIQ. What is the question, right? So I literally write out, even though it's already on the sheet, I literally write out, okay, from, like in my own sort of way, from t equals 0 to t equals 8 seconds, right? Because this whole thing starts at t equals 0. We should talk about what t equals 0 means. Whenever your stopwatch starts, it means when an experiment begins. It means when the clock started, t equals 0. It doesn't mean the Big Bang or the Garden of Eden. It means when you started, you, the experimenter, the researcher, started paying attention to the experiment. So the question was, from the beginning of the experiment to the end of the experiment, from t equals 0 seconds to t equals 8 seconds, what is the total? Sorry, the question is, that's the question, right? Now, right here, well, I'll answer the question, then I'm going to do a sidebar. But so, all right, maybe we even said this last time. Maybe I already did this question. I apologize, but that's the question. WIQ, the question is, what is the total displacement? You write that down before you even start answering it. It's not the exact words that I used. It's your words, but it gets all the information across. The question is, what is the total displacement? That's step 2, WIQ. Again, if you're ever handing anything in, especially an exam, and you think you're doing everything right, and you think you got the right answers, but you see -2 off to the side, and it says -2 WIQ, that's what I'm saying. I'm saying, wait, before you proceed, I need to know what the question is. And again, there's 1,000 super, I think, legitimate reasons for that. But whether you like the reasons or not, it's the case. So WIQ, there's the question. What's the total displacement? Now we go to step 3. GDP, general definitions and principles. So now we're going to write down something in general that is true, i.e. true across the board, even before, not only true in this question, not just a fact of this question, but a universal fact, such as a definition. This is generally a triple equal sign moment. I think I discussed this with you guys last week. Let me know in the chat if I did not. But so for step 3, GDP, I'm going to write something down like, okay, note, so obviously I'm about to turn the page of the board here, but notice it's getting a little crowded, but notice for my step 3, I'm writing down a triple equal sign. I'm writing displacement in general means final position minus initial position. I'm not saying that's the only way to define, I mean, it kind of is, but I mean, you might have slightly different words for that, or you might have symbols for that, which we're going to get to in one moment. But the key thing is, please notice, I'm writing, it's not the answer to the question. It's something that you might think is totally obvious. I mean, it was written on the sheet, but it's something that has to go through your brain, through your mind, before you figure out the total displacement for this particular circumstance. You must first know what this total displacement is, how to get it in general, and then you're going to apply that to this circumstance, right? So the first, again, these things that you think are obvious are really worth writing down now, because again, when we finally get to anything that's not obvious, the only way to figure it out is to break it down into a series of seemingly obvious small steps. So one of them is always to write something that's generally true before you even try to make it relevant or particular. All right. So what's generally true is that displacement is defined to be final position minus initial position. And that, and I might add that that's taking into account, that's accounting for direction, for plus and minus signs, right? It's assuming that there's a, when I say final position minus initial position, it's assuming that positions in one dimension can either be to the right of zero or to the left of zero. And if they're on one side of zero, we designated them to be positive. And if they're on the other side, we designated them to be negative. That's what that assumes. So, so it's going to, so displacement is something that takes into account negative signs, and displacement could be negative in the final analysis. I'm going to pause now and say, okay, this is a concept now, right? Like, I'm not saying, hopefully you don't find this too hard, hopefully, but please note we are saying things now. Like question 1 was about distance. Question 2 is about displacement. That's 2 different concepts. That's 2 different definitions. And when applied to the same circumstance or the same experiment, they yield 2 different results. So now things are starting to get conceptual, and they're also starting to get very verbose. I'm always very verbose. So let's now take the opportunity before I, well, actually, all right, I'm going to get an answer. Well, no, yeah. I mean, again, look, if you're at the edge of your seat, the answer, like we said yesterday, is -9. I mean, the final position is -4, and the initial position is +5. So when I do the work in a moment in step 4, I am literally going to say -4 sorry. Oh, I just said that backwards. The final position, the final position is -5. That's where he ends up after all that time. The initial position where he starts is +4. So the displacement is the final position, -5, minus the initial position, +4. So it's -5 minus 4. That's -9 feet. That will be our answer. That is our answer. And I'm going to write it down and work that out in step 4. But, you know, we're already getting to the point where working this out really could be a little bit more efficient if we start introducing some symbols and some equations, if we start making this look a little bit more like math. That might be a major relief to some of you. That might be a major fear factor to some of you. I encourage you to think of it as a relief. So I'm going to say, so here we actually. Okay, we're going to start getting mathematical now. Now, two things. Again, I mean, there's a method to all this madness. Like physics does ultimately look like math to a lot of people. Physics does end up being very mathematical. Math is the language of physics. They're not the same thing any more than English and history are not the same thing. But the language in which you write history papers and so forth and read history articles is English, right? Okay, so the language for physics is math. Now, for some people, they think that's a block. I mean, so this was going to start accelerating and start looking much more mathematical. Part of the reason I spend a while before it even gets mathematical is I want to encourage everybody to realize that the math is just that. It is just a symbolic, efficient mode of expression for the ideas that already exist in your mind, whether you use math notation or not. Math is a symbolic notation. Mathematical ideas are ideas that are not necessarily any harder or weirder than any other ideas. So part of the reason that we've spent 2 days of talking about physics without even introducing any math yet is I want you to see that any math that we're going to do from here on in is just a more efficient way of expressing ideas that we could always back up and describe or express or communicate in English. So on the one hand, please, as the math gets more mathy, please always try to bring it back in your mind to intuitive concepts expressed in your native language. On the other hand, if you're dying at this point, if you're like, my God, like this class is so inefficient, like he just talks and talks and like we're not getting anything done, you'll start feeling like we're getting more done now that the math is going to come in. But I want you to see too, like I almost do this almost kind of on purpose so that by the time the math comes in, you're relieved by it. So you see how, I mean, this is how civilization works. We introduce this math notation so that just so that we can be more efficient and breathe more easily through these ideas. It's not meant to get in the way. It's meant to clear a path. And hopefully maybe you'll feel it that way if we go in this fashion. So what I'm saying, from now on, any position on a number line, any coordinate in space, the value of any spatial position, we're going to, from here on, and designate with X. We might also use Y and Z once we get into other dimensions, but we use some letter from the end of the alphabet, like X, to mean your spatial coordinate. X has a value that, and because it's a science, that value will have units. X could be like 7 feet or -3 meters or whatever. And that's the point in space where some object is. So it's a point, okay, X. Similarly, oh, sorry, I just skipped one. But okay, similarly, T is a point in time. So the value of T is some instant in time. The value of X is some position in space. I should have said, so T equals 0 just means whenever we started paying attention to some experiment and we started our stopwatch. In other words, time is a line and it has negative values and positive values too. It's just that negative generally means before we started paying attention or caring. So generally speaking, negative time values won't refer to anything that we're actually talking about in a given experiment, but they're not contradictions or something like that. So T equals 0 is the first instant, the first moment in some experiment or some set of observations or some thought experiment, such as this one with the guy going back and forth at the front of the classroom. So you probably knew all that or have seen all that before, but now I'm going to add something that if you took high school physics, you've probably seen, but maybe you haven't. If you ever from now on see X with a 0 after it, a 0 subscript, the way we read that out loud and say it to each other, we read that as X. It's read out loud as X naught, N-A-U-G-H-T, or sometimes spelled N-O-G-H-T, but not as in British, or, as in British for nothing. Okay. So if I see X with a subscript, a 0 subscript next to it, I read it out loud as X naught. And what that means is the value of X when specifically time equals 0. So it means the very first value of X in a given experiment. From now on, for all time, we're going to use that a lot. Okay. Again, and it turns out we use that same notation for any other kind of variables that we're going to introduce soon, like maybe today or maybe not. Like, so this squiggly line that I have underneath the X, I just have like squiggle, that's just meant to be any arbitrary variable that we haven't introduced yet. Like it could be a V for velocity, or like F for field, or something, like any symbol or any symbol at all that you can think of. If you put so any symbol can be used as a variable to measure the value of something in an experiment. And if we put a 0 to the right of it, we mean the value of that variable when t equals 0, the initial value of that variable. So from here on in, if you ever see X naught, that means the initial position. If you see like V naught, it means like the initial velocity, etc. Okay, so that's notation we're going to use from now on. Therefore, stop me if any of this doesn't make sense. But you'll notice that each one of these variables all we have for the rest of physics, we have stuff moving through time and space. That is physics. Motion of things through time and space. That is physics. Like, it's not always necessarily easy, but it is very simple. It is things moving through time and space. That's all there is. So notice that time and space, t and x, when we measure them, we're measuring like t, the value of t is always some coordinate on a time axis, and x, the value of x is always some coordinate on an x-axis. That is, they are points. They are points. They're very exact, very specific, very precise points. They're not intervals. If we want to talk about displacement, from now on, if I want to talk about displacement, right? Displacement's not the same thing as position. Displacement is final position somewhere at the end of some interval that I'm looking at minus initial position. So it's the position now versus the position earlier on at the beginning, right? That's what displacement means. In other words, displacement is an interval or a segment or a difference or a relation between two positions. From now on, if I ever wanted to track displacement, I would write x minus x naught. Note okay, I'm still all under my sidebar here about symbolic notation. I will go back to, and I'm not saying, by the way, I'm calling this a sidebar. Everything right now, I'm saying this is still a sidebar. And what I don't mean, hold on a second. Okay, everything I'm saying right now is still a sidebar. Let me be very clear, or try to be very clear about that. When I say it's a sidebar, I do not mean it's not important. I don't mean you like you could ignore it or something. In fact, it might even be more important than a lot of the other things I'm saying. When I call all of this a sidebar, I am not saying ignore it or it's a parentheses. What I mean by calling this a sidebar very specifically is that I wouldn't expect you to be writing all these things out if you were turning in your homework. Okay. If I'm showing you what to do on your homework and I'm up to step 3 right now, and I wrote step 3, displacement equals final position minus initial position, then all of this right now is a sidebar in the sense that I am, as a professor, talking to you as a student, explaining something that you can from now on use in your homework. But I wouldn't expect you to write all of this. Okay, that's what I mean. So that I don't want to confuse anybody. So it's a sidebar because I'm talking as a teacher right now. Okay, and then I will go back. I will go back to the question. But part of this sidebar is I'm from now on, because again, we're trying to take these English ideas and translate them into mathematical symbols so that we can be more efficient in the future. So from now on, if I ever want to talk about displacement, I'm not going to write down X. I'm not going to write down X naught. I'm going to write down X minus X naught. That's what I mean. That's like a symbolic expression for displacement from now on. Please notice, though, what I'm saying up here. X naught, here's an example of a triple equal sign versus a double equal sign. X naught triple equal sign X of 0. It means X, the value of X at time equals 0. X naught means the value of X when t equals 0. It does not, notice it is not defined like triple equal sign with line through it. X is not defined. Oh, excuse me. Oh, you know what? Good thing I'm saying this. I'm confusing myself. Hold on one second. I'm saying there. I'm saying X naught is defined to be X when t is 0. X naught is not defined to be 0. X naught may well be something other than 0. Like it could be 0. So this is a distinction between a triple equal sign and a double equal sign. X naught is not defined to be 0. X naught could be 0 sometimes. Double equal sign. It could be, but it isn't necessarily. And in fact, here in this problem, okay, so here, X naught, whoops, sorry. X naught in this problem happens to be, I should almost ask this in the chat. Actually, I guess I will ask. Yeah, I'm going to pause for a second just because I'm talking so much. If anybody wants to put in the chat or shout out, here's my question. In homework 1, in general, for the entire experiment of homework 1, what is the value of X naught? Like, what's the initial position of the instructor who's running back and forth? Like I'm telling you right now, X naught does not equal 0 for this homework 1. Like it, yes, that was fat. Awesome. Yes. Thank you. Who's that? And you can do it in private or public. And yes, notice a lot of people look, and you can still say it. You can still say it, even though I'm noticing that people are saying it. Like it's not too late. This is not a competition, but I'm totally psyched. And if nothing else, it's just showing me that we're still together, which I appreciate. But like definitely, so you could still say it. Plus, I'm excited. I'm going to admit something, not you. I'm excited because I see all these answers in the chat. Okay. Honestly, do I know that they're the right answer? Yes, I do. But I didn't say they were there. I'm just excited that they're there. Even if they were wrong, believe me, I would be excited. And also you could submit to that portal where you get wrong answers. I think we talked about, but yes, thank you, Felicia. Thank you, private chat person. Thank you, Caitlin. Thank you, Amy. Thank you, David. Thank you, Kimberly. Thank you, Chloe. Thank you, Amanda. Thank you, private chat person. Thank you, private chat person. Thank you, Nicholas. Thank you, Kevin. Thank you, Samuel. So yes, and I mean, serious thanks. Thanks for being alive still. Yeah, okay. So you get it. So I'm also going to take that as a hint. I can move on. Yeah. So X naught doesn't have to be 0. It's actually 4 in this case, because that's where the dude starts. So to finally get back to going over homework and to move a little faster. Okay. So back to the homework, back to question 2, continue. Well, back to question 2. If we go to step 4 now, PAW, right? in step 4, particular application and work, now we can say, okay, we've got a general definition of displacement. It is x minus x naught. So here, x minus x naught, here, in this case, double equal sign, right? So, okay, in this case, equals -5. Well, I could even, all right, to be super specific, I suppose I could say, sorry. I mean, I'm getting a little bit stupid here, I suppose, but like x equals the final position equals -5 feet. Like that's where he ended up at the end of the whole of what we're looking at right now. The initial position was +4 feet. So x minus x naught equals -5 minus +4, right? So that's my step 4. And then finally, in step 5, step 5, fact, final answer circled, we would say for my final answer is a complete thought, like displacement equals -9 feet. So my final answer is a complete thought. It's displacement. And now it's a complete thought. It's a complete thought, but it's now increasingly written in mathematical language. The complete thought is displacement for the whole journey equals -9 feet. I could even, if I want to be a little more specific, like that's for the whole journey from t equals 0 to t equals 8 seconds, right? Equals -9 feet. So my final answer is a complete thought, i.e. it has an equation sign in it. It is not a fragment. It is a complete thought. It is an equation. It's not a law. It's just an equation that describes what's true in this case, right? It's a double equal sign, not a triple. Oh, and I'm going to look in the chat in 1 second, sorry. And then also notice that it's circled, which is really important, or it could be highlighted or bold-faced or bitmojied or whatever, but it's definitely, and I'm going to, oh, sorry. Oh, wait, sorry, great. There's a private track question that's totally great. Sorry, and I see I look into, it's totally great. I'm going to get to it in 1 second. Let me just finish this thought. But no, totally. The answer is yes, private chat person, but I want to say, so yes, so no worries, but I'm going to go back in a second also. But let me, oh, another question in the private chat. Okay, there's a couple of, and keep them coming. I'm going to answer all of them. Let me just pause for a second and get my like feet on the ground, but this is the final answer. Okay, and it is circled, and I want you guys to notice a couple of things. Well, first of all, wait. All right. I want you all to notice a couple of things. There's a couple of good questions in the chat. I'm actually trying to make a decision which one to do first. But first of all, one thing: if you miss anything on a prior slide, whoa, hello. If you miss anything on a prior slide, please tell me and tell me to go back. Like someone in the private chat in one question is maybe implying that maybe they missed something in a prior slide. I'm not sure which slide it is, but it's totally legitimate to ask me to go back, people. I mean, please, like it makes me think you care if you do that. I mean, it makes me know you care if you do that. I don't mind going back at all. I talk fast because I get excited and I'm afraid of boring people or whatever. But we're not in a rush. I make people feel like we're in a rush. We are not in a rush. Sometimes we are, and I'll let you know when those times are. If anybody in this room ever needs me to go back to another slide, please let me know. If you want to let me know in private chat because you don't want to like to have the class think that you're slowing them down, fine. But I guarantee you, if one of you is trying to take notes and one of you needs me to go back, you're probably not the only one on it. Or if you can't read my handwriting, like all of you, see, I sound upset, but I'm not upset. Things like, wait, I can't read your handwriting, or wait, can you go back a page? They might seem stupid to you if you're thinking it, but to me, they're like the ultimate forms of communication. Like only someone who cared, who's in this class, would ever care that they can't read my handwriting. So please let me know. and you're probably not the only one. Like I am here, like really all of you. Okay. So if I have to go back a slide, if you want me to go back a slide, please let me know. It always makes me feel like, oh, thank God someone actually cares. Really. Okay. That's number one. But number two, so I don't know. I think someone wanted me to go back somewhere, but I don't know where. So I don't know if this is helping or not, but here are, but number two, yes. Oh, it is also true, to answer that private chat, all of these slides, so to speak, this whole whiteboard absolutely is bundled as a PDF, and absolutely, unless I make a mistake or something, let me know, but it's generally it's dropped as a PDF right into your Google Classroom right when the class is over. Like occasionally I think I'm dropping, then the attachment doesn't go, so please let me know if I do that. That's not on purpose, but usually as an attachment, this goes under class notes. You have a category called class notes. After every class, it will drop in. So you will get all these notes. But oh, great. Okay, thank you for the thank you. Got you, private chat person. But I want you all to know too, it's also true that a recording of this class will in a few hours drop into Google Classroom. All those resources are good, and I hope you take advantage of them. But the reason for all the resource is that no one thing does everything for everybody. So please know, yes, I consider part of my job to give you all these notes afterwards, but really, they don't do you any good unless you're trying to take notes too. You really do want to take notes. So don't think if you miss something, don't think you shouldn't ask me because I'm dropping the notes as a PDF anyway. They're two different purposes. You all should be, just like in traditional classrooms with the board in the room, like this. If you've survived this long in science, there's a reason you need to be writing things down your way. I'm just also writing things my way, and together they help you learn. I mean that to everybody. So on the one end, yes, please note that these notes will always be there for you, but don't use that as a reason not to take notes or to not stop me. And same thing with the YouTube stuff. Okay, but okay. Then also, but thank you for the thank you. Now also someone else asked, I'm going to go back to one secret of all that, if you do everything, like no one ever knows why anything exactly works. That's why we do everything. But again, for those of you who are getting, the class will get, or the material does get more and more advanced, and I do go faster and faster. I keep saying that because I know I'm driving certain people crazy with how inefficient I am. So I just want you to hang in, okay? It will get faster, but I also want you to know, on the other hand, if you do everything and hang with me, if you take notes during every class, if you try all this homework, even when you don't know how to do it, or even when you don't right away get a grade back or something, if you do everything and keep paying attention and you do take notes, and then maybe even occasionally you do look at the notes that I dropped at the, it's designed so that then by the time you get to a test, you won't even have, you're always practicing. And then the test is like the recital. And so if you're practicing enough, then when the recital comes, you've practiced and you're ready for the recital. Like, I mean that, like, it's not like there'll be suddenly new information the night before that you didn't. Anyway, I'm just saying it's right to just keep with me. But now someone else asked, what did they ask? Oh yeah, so someone asked in the private chat, if we did the question differently, but still got the same answer, is that okay? That's a very subtle, very important question. It's subtle because there's like a spectrum of possibility to that question. On the one hand, ideally, you do want to do the question in your own style. As we progress further and further, the way I'll know that you're actually learning this and getting this stuff is because your work will always look slightly different from mine. Stylistically, in the way you phrase things and the colors you use and stuff will be different. And if it's exactly the way I'm doing it, if ever anybody's doing it exactly the way I'm doing it, that's a bad sign. That's true. On the other hand, this is a very fine line we're walking here. This is a subtle thing, because on the other hand, what I am saying is you do have to include all these steps. And that is new for many of you, and it'll annoy some of you at first. I am saying it's not, to the private chat person and to everybody, it's not good enough just to get this answer. I am saying that if you just wrote this answer down, even if it's right, that you won't get full credit. In the same way, you in order to get full credit, you have to do all the steps, especially if it's on an exam. And if it's homework, you have to do all the steps. But if it's homework, you don't have to do them all the first time. You can revise and resubmit late and eventually get all the points. Eventually with homework, you have to do all the steps to get all the points because you're practicing all the steps that you would do on an exam. The bad news is you can't just have the right answer. You can't. You have to do all the steps. The good news is that means that even if you don't have the right answer, you can still get tons of points. It means that even if you think you don't know what to do, there's a lot to do, even without knowing what to do, that gets you a lot of points. That's the secret purpose of all this. When it gets harder, you'll appreciate this more. So the person who's asking if they did the question differently, the most honest thing I can say is if you did all these steps, but some of the steps look very different, particularly step 4, as things get more and more advanced, your step 4 will look very different from mine, and it might have very different approach, and it might have very different internal steps. Great, great. Each of your steps will look a little different from mine. They might look very different, but they do all have to be there. You do have to have the 5, you have to acknowledge the 5 things. So I don't know. So that's a very subtle question. And I hope the person who asked me that, oh, okay, cool. Awesome. You guys are great. All right, awesome. So, okay. But again, that's a kind of, anyway, good. Okay. So I'm going to keep going. So that's the answer. Oh, and finally, look, now again, I'm so defensive. I know I'm a defensive guy. I'm like a used car salesman for physics or something in reverse. I mean, I know most of you don't need to be hearing most of what I'm saying right now. I know most of you got this answer without 3 days of dragging this out. I know that. But what I'm trying to say is you also know in your heart, you've heard physics is hard. And if you're thinking like, can we get to the hard stuff already? Like, why is he doing this? Like, we got to get to the real stuff that's actually hard that I'm scared of. What I'm really trying to tell you is we'll get to that stuff, but it doesn't need to be hard. It won't be hard if you do this process on things that at first look hard. Right now, I'm driving some of you crazy because I'm taking something that you think you know already and I'm stretching it out to this long thought process. What I'm guaranteeing you is if something flashed in your mind as a photograph of instant brilliant knowledge, if all you just looked at the question, you're like, boom, -9 feet, let's go on. What I'm saying to you is don't insult the question, don't insult me, and don't insult yourself. If -9 popped into your brain super fast, don't think that's because it was a stupid or obvious or easy question. Think it's because you're intelligent. It came into your brain really fast because what actually went through your brain was a movie of 5 frames. And that movie flickered through so fast that you thought it was just one snapshot. But your brain could not possibly have, if you think about it, no way did your brain know that it was -9 feet, -9 feet, unless your brain first knew what displacement meant and first knew what the facts were of this situation, and first knew what question was being asked of this situation. If what was being asked is, what is the displacement in this situation? Your brain had to go, well, displacement in general means, blah. Oh, and if I apply the facts of this situation, put them together, then I get displacement equals -9 feet. You had to do all that. What I'm asking you now is undergo the pain and the torture of actually noting what you did in your brain, even if it was really fast. Because when we get to a question that you look at and you go, I have no idea what to do. What I'm telling you is, yes, you do. Yes, you do. Do what you've always done, which is first write down the diagram and the fact, then write down the question, then write down general definitions or terms that have to do with the questions. That's 3 steps that everybody can always do when they look at a question, even if they think they don't know the answer. And then you're 60% of the way there. Then you start applying and now you're 80% of the way there. Most people, when they look at, okay, I'm going to move on a second. I know you're like, we didn't ask for this. Could you just move? Okay, I'll move on. I will move on. I want to say, so like right here, I know this is good physics because this circled answer at the end, it literally says, not only here's the information, but it says, here is the answer to the original question that was asked. Like I've closed the loop. I've closed the conversation. Originally, I was asked, what is the displacement for this whole thing? Here is the displacement for the whole thing. So I can take your homework. If you did this for question 2, and I will move on. I have 15 more minutes. I will move on. But please note that one of the litmus tests of good problem solution, good homework problem, or a good exam problem is you could now take this. So this is also basically back to the direct chat person who asked. Like, yours will look very different from mine, but you'll know it's fully comprehensive, thoroughly complete if you could take the whole thing, hand it to someone else who didn't know the homework assignment, but does know physics. You could hand it to Professor Walters or Professor Liu or whomever, Professor Melendez. You could hand it to them and say, what do you think of this? And they could read through the whole thing and be like, oh yeah, you nailed it. Oh yeah. Oh, I never thought about that before, but that's good physics right there, right? This is complete on its own from beginning to end. It shows what physics needs to be done for this situation to get this answer. No other documents necessary, no other outside knowledge. All right, you get my point. You get my point. All right, so I'm going to go on to question 3. All right, I'll start going faster, I promise, sort of. All right, question 3. Question 3. All right, so first of all, see diagram above. Okay, now, as I said, I'm going to start going faster and faster. So now I'm not even going to write in the margin anymore, step 1, step 2. I'm going to do step 1, step 2, step 3, but I'm not even going to write them in the margin anymore. I'm up to you to track that with me. All right, so I did step 1, see above diagram. Now I'm doing step 2. What is the question? I believe the question for this one is, oh yeah, I believe the question, and stop me if I'm wrong, but I believe now we're into a new thing. The question now is, what's the average speed for the whole thing, I believe, right? So I think the question for this, but stop me if I'm wrong, from t equals 0 to t equals 8 seconds. What is it? Whoops, sorry. Right? So that's, oh, thank you. Thank you, Carolyn. Awesome. Thank you, Amy. Oh, I love this class. Woo woo. Okay, okay, good. Thank you, guys. So the question is, what's the average speed for, not the, yeah, what's the average speed for that entire interval? So that was 2, step 2, WIQ. Now I'm going next page. You can, question 3. Continued. And again, notice I've referred to the above diagram. So the above, I mean, it's at the top of my sheet of paper here. It's just my sheet of paper is like many screens. All right, so question 3. So now I'm doing step 3. General definitions and principles. So I'm going to say average speed triple A. Right? So that's my step 3. In general, from the sheet, the definition of average speed is a total distance covered in some process, some experiment over the total time. Now I'm staying in English here. I don't really have notation. You notice for distance and speed. Okay, actually, quick sidebar. Quick. Well, no, I'll get the answer and we'll decide. Well, I'll just say the sidebar really quick. Just notice distance and speed. Those are quantities that don't concern themselves with direction. They don't have plus or minus signs, distance or speed. They're like absolute value things. They're technically called scalar quantities. Please do actually write that down. I'm not going to get myself bogged down here, but like sidebar, distance and average speed are known as scalar quantities, S-C-A-L-A-R. Scalar, meaning they just show you the scale, the size, the raw magnitude of some measurement. Whereas, in contrast, displacement and velocity, those are vector quantities. Those are quantities that do take into account direction, plus and minus, positive and negative. It's the vector quantities that ultimately we're really concerned about in physics. Like those are the more precise, more information-rich quantities. They're the ones that we symbolize with X and T and all that stuff. So I will, like, there's most of our equations deal with these kind of vector quantities. Here in the sort of raw scalar quantities from which we build those others. Here I'm still sort of in English. The symbolism for this is clunky. So I'm staying in English here, but in English, I'm saying for step 3, average speed is defined in general to be total displacement over total time. Then I'm saying here, now here, this is step 4, here, total distance, double equals sign, 21 feet, and total time, well, sorry. Okay, so now here, so again, I'm trying to speed up a little bit. I'm now in step 4. I'm doing a particular application and work. I'm taking the particular facts of this problem. In this problem, the total distance apparently is 21 feet. How do I know? Well, I figured that out in question 1. So I wrote that CQ1 above. Total time is 8 seconds. That's part of the givens. It was 3 seconds plus 3 seconds plus 2 seconds, right? So here, whenever I say here, I mean like in this particular situation, so now my final answer actually, let me hold on a second. That is correct, but I'm just moving this over. Hold on a second. Looking at the time. Okay. So I'm going to pause for a second. Okay. Wait, is that right? No. Yeah. Yeah. Okay. That's my final answer. You could write it as a fraction. You can leave it as an improper fraction. You could write it as a decimal. You can include all the decimal, all the significant figures because we're not really rounding it. I'm not worried about that at the moment. But that's a final answer. Notice it's a complete thought. It's like 2 different ways of saying the complete thought. Either one is acceptable. I'm not saying you have to write both. You could write either one. But the average speed is 2.625 feet per second, or 21/8 feet per second. That's the final answer. Again, and here I'm trying to go. I still, this is an example. Everything I did here, you would have to do somehow or other in your homework. Again, if you didn't last night, you can revise it and resubmit it even before I look at it. It's fine. I'm sorry that I'm behind already, or not, whatever. But that's what I'm looking for, even if your style is different. And we've got 6 minutes. So I think I'm going to do one more if everybody's cool with this. But as you see, like I'm trying to get more and more efficient. I didn't write in the margin step 1, step 2, step 3, you can, but if you check, you should see that all of my steps are here. 1, 2, 3, 4, 5. Like that's always the standard for a quantitative problem to be solved, is those 5 steps. So that's my answer to that one. Now I'm going to try to sort of quickly just do one more and then we'll call it a day. And I think it's clear what so you just keep going with the homework. I'll look again exactly what I said about due dates and stuff, but here's the deal. Yeah, we still have like 2 more homeworks to go over that we haven't even looked at yet. I know that. So you'll notice, wait, today is Wednesday. So even though there's a lot, so I might, just to keep things going because it's a long week, because we have like 5 more days, I might post one more thing for Monday, but probably not. Like I need to catch up with you guys, and you might be seeing that you need to do revisions. Oh, sure. Okay, hold on a second. So there's something important in the direct chat. So what I'm just trying to say right now is basically for the weekend, we all want to catch up. I want to catch up on grading your things. You still have the other sheet, average speed and train of thought to do. They don't involve any new concepts that like we need to talk about here in order for you to do them. You might have an easier time doing them now with some of what we've done here. Again, let me repeat with train of thought, you don't have to do this 5-step method. That's the one sheet where you don't really have to do it, but number line and average speed you do. I will just keep going on Monday. I'm going to just keep going with this. I'll go faster and faster. Then I'll get to the average speed, and then train of thought will be like a side day. So hopefully it's clear what most of you are ahead of me now. Most of you, I owe you something back more than the other way around. I want to do one more question, but can I repeat the sidebar? The first part when you mentioned distance. Yes, you mean yes. Wait, so someone's asking me to repeat the sidebar when I mentioned distance. Oh, do you mean? Wait. Sorry. You direct chat person. This is a very fair. That. I'm sorry. Yeah. Okay. You know what? That's such a fair question, important question. I'm going to answer that right. I'm going to write down the answer to that right now. I'm not going to do what the answer to. Okay. So someone's asking me to repeat, and it's worth it. The sidebar about mentioning displacement and velocity or vector quantities. I'm going to write that down for everybody right now. That's very worth it. Thank you. And definitely put that in a class participation portal for real. Okay, there's 1 minute left. So this is where I will say the answer to question 4, if anybody's tracking or if anybody cares, the answer to question 4 is -9/8 feet per second, like -9/8 feet per second, or put another way, -1.125 feet per second. That's the answer to question 4. Again, there you'd have to show all the work just like I just did. But if you're like just trying to know if you're doing things right, the answer to question 4 is -1.125. Negative, and it's negative. It is negative. Velocities can be negative. So the sidebar thing that someone, thank you for asking, is I'm saying what we've established here is that there's 2 types of quantities. There's scalar quantities, or scalar measurements, which are just raw amounts, raw magnitudes. They're called just sizes. And then there's vector quantities. Vector quantities include size and direction. In other words, it's a richer, larger concept. So distance is a scalar. Displacement is like distance and direction. It's a vector. Average speed is a scalar. Average velocity is like average speed and direction. It's a vector. Right now, in one dimension of space, by direction, we just mean whether something's going forward or backward, or left or right, or north or south. So we can just use plus and minus to designate that. So vector quantities can be positive or negative. Scalar quantities can only be positive. That, oh, great. Thank you. Awesome. So I think that's a perfect place to end. So it's 1:30. So again, like, thank you. I'm going to hang out just in case there's any questions or anything. Again, I apologize that I haven't gotten you back. Question, homework one yet. I'll still take my time, but you still have time to redo. Blah, blah, blah. You can all still get full scores on it. But if you want to go, I'm just changing the view. I'm here. So yes, goodbye. Thank you so much, all of you. Thank you. Thank you. Just have a great day and a great weekend and all that. But I'm just here.
Bye, Professor. Have a good day.
Thank you very much. Good job. Awesome. Awesome. Have a good day. Thank you, Elda. Have a good, thank you. Awesome. Bye. Have a great day. Thank you. I like that, Rose. So thank you.